Welcome to the Rich Report, a podcast with news and information on the world of cloud computing. Today, my guest is from Morph Labs. We have Kaz Brescher. She's VP of Business Solutions at the company. So, Kaz, welcome to the show today.
Thank you so much. Thanks for having us on.
I'm glad you could join us. I brought your slides up. I've been learning a lot about mCloud, but I thought we'd start there and have you present, and then we'll follow that with a Q&A.
Excellent. That sounds good.
Okay, go ahead.
If we dive in, I figure on the second slide, we can just do a very quick background on where we come from, because in fact our background really shapes the direction we've taken in the cloud computing industry. The company has actually been around since 2007, so we're the old, long in the tooth folks in terms of the cloud computing world. And we really started out with a focus on open source and commercializing open source so that we could lower the barrier to entry for cloud computing and make high availability and high performance available to new sets of customers. And our management team actually has that kind of background. And when we began, we started off with a PaaS layer on top of Amazon. And what we realized was that many, many users adopting cloud these days are still struggling with basic infrastructure as a service. So we became an initial member of OpenStack and have sort of scaled our product back to the ground level, and we're building back on top of that. And so we really do want to focus on optimizing the cloud architecture itself at the infrastructure layer, and then enabling dynamic, high-performance, massively scalable infrastructure of the style that Google and Amazon and Facebook have all pioneered, sort of so-called hyperscale computing. So we have a global presence, and that also brings a unique perspective to what we do. And if you go to the next slide, slide 3, it's obvious at this point that cloud has a very, very broad adoption rate. But we thought that this was very interesting. Forrester came out in the middle of last year talking about what they call dynamic infrastructure services. That's actually the private cloud equivalent of infrastructure as a service. And what's relevant about that, especially from my position, since I spend a lot of time talking to analysts and talking to our customers, security and quality of service, guaranteed performance, those things are critical for adoption of cloud. And what we're starting to see is that public cloud itself is being commoditized and flattening out, and dynamic private cloud is likely to become the fastest growing segment of cloud computing as we see in the coming years. And of course, on top of that, you can have platform as a service and software as a service. So with that in mind, if you look at slide 4, this is what we backed into. We really took a step back and said, okay, let's look at the current landscape of enterprise architecture. And we really feel that virtualization-oriented systems are ripe for disruption, in part because of the architectural structure itself. So when you start out with really dense blades at the base, you have that fixed capacity, and that's typically a stumbling block for private cloud. We'll come to how we've solved that later. But then those dense blades require very, very complex networks in order to use a SAN effectively. That results in a specialized skill set needed to keep that system running. It's monolithic. It's quite fragile in terms of its balance. And if you really want it to be highly available, the cost per VM, per virtual resource, becomes exorbitant. And this is actually the kind of thing that you see out there stemming from VCE Alliance and the like. So what we did was we said, let's figure out a way to really use the agile, more modular hyperscale approach that is growing and proven successful in the large companies I mentioned. And if you look at slide 5, this is where we've netted out. So the mCloud solution essentially is innovative at the core because it disrupts monolithic architecture. Everything on top of that, even though we're a software company to begin with, the innovation is really in the convergence of the software and the hardware, and you'll see what I mean in a moment. So basically, we feel that this kind of system, which is a Lego block, hyperscale, modular architecture, is going to enable broader adoption, both in the enterprise in kind of first world countries, but also across the developing world. So what we've done here is we've put SSDs in throughout the system, not just in the storage nodes, but also close to the compute nodes. And what that does is it reduces the need for using an expensive, hard-to-maintain SAN, and instead creates these kind of modular elements so that you can start to compose a data center set of resources using software. We call this software-defined data center. So in doing so, we've been able to redefine the price performance per VM and per terabyte of storage. And it also then, of course, lowers the entry footprint. So you could have a complete set of infrastructure of, very robust slice of data center, essentially, for under about $150K. And that also allows scalability in the private cloud. By using this kind of Lego block approach, we are able to then add compute nodes and storage nodes on the fly while retaining share-nothing infrastructure. So scaling with dedicated resources, and we'll come back to that. So if you look at slide 6, what we've essentially done is we've created a rack, a mini rack. It's fully converged cloud infrastructure, and like I mentioned, it is an all SSD compute model, and that brings us gains of up to 10 times the IOPS that you see on current cloud computing solutions. And by being able to dedicate hardware, you have not only security, but you have guarantees in performance, which has been a big stumbling block in the public cloud realm. So we're using the modular storage nodes, like I mentioned, and that allows massive scalability. We have a ZFS-based enterprise file system, so we've got really stable and, again, scalable future-proof storage. That's critical for us. Software-defined networking, which comes out of our mCloud controller, and then you've got multi-hypervisor support and multi-formats for VMs because we believe in the open ecosystem that is going to ultimately improve cloud for everyone. We also have noticed as we started working on this that the DevOps gains, and I know the DevOps movement is growing quite rapidly, in fact, that the automation tools are a big benefit as well. And this is where we start to get into the software elements that mCloud provides. And we have an integrated support model as well. So if you look at slide 7, this is essentially a schematic of what the mCloud Rack Enterprise Edition could be. And this enterprise rack can live on-premise. And the idea is that you start with a base capacity, in this case about 160 VMs. They're all SSD, about 12 terabytes of storage, and you have a 10-gig switch at the top. And then you've got load balancing and all your DNS servers and firewalling. And then you have a scalable frame, which allows you to burst out to up to over 500 VMs per frame, let's say. So you have this kind of external expansion for bursting, and you have the ability to add internal expansion as well. So you could burst out to remote storage, you could burst out with additional computes when needed, and we'll talk about that in a moment and how that part of our technology has been a real win for us, I think. If you look at slide 8, this is a slightly larger format of rack. This is the mCloud Rack Service Provider Edition. And this allows the telcos who have really been struggling in the cloud space to compete with Amazon finally. In bringing down the price for these kinds of resources, they can finally offer something that's a competitive offering to Amazon, but retains the benefits of private cloud. So again, dedicated hardware, share nothing, and guaranteed performance. So essentially what they do is they sell through to their customers what we call an mCloud data center unit. It's a slice of a data center. And it's composed of an mCloud controller, a compute node, and a storage node. And this kind of base capacity for the service provider then allows them immediately to start selling DCUs to enterprises who might not need as many base-level VMs to get started. And this scales into a multi-frame kind of offering and also allows scaling between sites. So if you start to look at the telcos who have multiple locations, that brings in elements around disaster recovery, business continuity, and additional services. If you look at slide 9, this is just a closer look at what the mCloud Data Center actually gives a user. It's full technical control, and that's not a marketing line. We've spent a lot of time over the last 5 years architecting that in. And so essentially we group the benefits into the infrastructure and ops services. So you can design services. There's full metering and account management, the configuration management that we talked about, licensing. And that really allows policy enforcement and the kinds of customization that you might need within an enterprise to be using these kinds of cloud services. On the developer side, they, of course, are able to self-provision, which we think is one of the basic tenets of cloud computing, manage applications and workloads, set up smart load balancing, create server templates for rapid automation of repeated tasks, and manage teams through role-based access controls. So that really allows automation of the low-level tasks so that these IT groups can start focusing on higher differentiation in the business itself. And then there's all the network services which are more relevant to someone like a telco or service provider who is actually operating this kind of portal with the DNS and load balancing and management. If you go to the next slide, which is slide 10, this is a basic look at what I've just discussed, but it's a little bit more visual and easy to understand. So in this sense, you start at the center with the mCloud Data Center unit, again, composed of an mCloud controller, a storage node, and a compute node. It's a basic set of resources which can then be consumed by a number of different users. You could have dev teams or finance, infra and ops, and that's essentially a private cloud. And that private cloud is served from an mCloud rack via an operator. And there are several shared elements in terms of the backups, but that's just for redundancy. And of course, like we said, there's a resource farm there that then can be burst to. So that allows the scalability with dedicated resources. If you look at slide 11, this is a quick look at what I was discussing with site-to-site bursting. And this is a part of our technology that we call dynamic resource scaling. And it really is about taking advantage of optimizing capacity so that we can use carrier Ethernet exchanges to use as much of the server and compute power that we can. As you probably know, the average right now globally is about 7%. Virtualization bumps that up closer to 50%, but we're hoping to get up to 80% utilization by being able to allow the telcos to burst from one to the other. So we've been doing a lot of work with the Metropolitan Ethernet Forum and the carrier Ethernet standard systems so that we could burst in this way. And then lastly, if you look at slide 12, private cloud ultimately can burst to public cloud, and these are the hybrid configurations that you hear much more about. And from a customer perspective, if we're leveraging OpenStack, which we are, the open standards really are going to help enforce interoperability, and that means no vendor lock-in for customers. So right now with the dynamic resource scaling, we're able to burst from our service provider rack, and on the roadmap, we will be able to burst for the mCloud Rack Enterprise Edition as well. If you look at slide 13, that's got our website where you can get more information if you have questions. And thanks so much, Rich, for letting me take you through that.
Well, thanks again, Kaz. So I was going to ask about OpenStack a little bit. What do you think were the prime attractors to you guys at Morph Labs for using OpenStack? I mean, was it because Dell's a big proponent of that, and they're your hardware partner? But what else was there?
Well, I mean, I think part of it, like I mentioned, Winston Demarillo, our CEO, has a very strong background in open source. He was a member of the Eclipse board and an Apache committer for a long time, and he's built multiple companies around Apache projects. So I think that the core of a growing, robust, dynamic open source community caught his attention right away. And it certainly seems as though part of the benefit would be that as the OpenStack community continues to blossom, really, that it decreases the code fragility for our customers and will bring more of the innovative benefits to them. So we felt, we actually yesterday announced that we are now one of the founding members of the OpenStack Foundation. And part of the reason we've done that is because our commitment to open standards is such that we really believe we can contribute leadership to this group as it develops. So that was a big reason why we jumped on board with OpenStack.
Yeah. And it seems to me you've built like this best of breed kind of a hardware stack, something I think at Sun we used to call it a reference architecture. Is this the first in a series of things like this that are tailor-made for certain kinds of virtual environments, do you think?
It's interesting that you ask that, in fact, because about 6 months ago, we launched what we felt was a true reference architecture where we said, okay, we've pre-tested and we really believe this is the optimal way to make use of commodity or hyperscale hardware combined with our software, and we found that people wanted us to still do everything for them and truly pre-integrate. So I suspect that we are actually looking at a variety of different types of hardware, but we feel that Dell's Data Center Solutions Group is most resonant with the same kinds of goals that we have for making this kind of high-performance computing available to all kinds of groups. So I believe that we will continue to evolve the modular approach as we make advances, just as we recently announced the all SSD configuration, and we really feel that that's the leading edge. And we've worked extensively with Arista actually on optimizing the switches for this kind of high performance computing. So I do think that there'll be an evolution, but this is, at the moment it's the culmination of almost 5 years of work on figuring out the best way to do this. And what we hope is that the evolution will include joint effort between other partners who are committed to this kind of open source approach.
Sure. And then as far as the hypervisor, the virtual environments you support, are you primarily VMware out of the chute, or do you plan to support other kinds of environments?
We actually have multi-hypervisor support, so I would say KVM and Xen are the two primary ones that we're supporting, but we do have, right now we can support almost all of the hypervisors out there, and it's really, I think, a business discussion. We've had different partners who have said, we need to use this, or we need to use that, but just as we're hoping to have multi-VM format support as well, we'd really like to be agnostic to those questions and really focus on optimization of the infrastructure and optimization of the DevOps gains, basically.
Sure. Well, Kaz Brescher, I want to thank you once again for coming on the show today.
Thank you so very much. Hope it was helpful.
It was. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of cloud computing.